Hello, welcome to the Semester 1 exam review packet. If you're one of my Algebra 1 students, hopefully you find this really helpful as you prepare for the final exam. Try them all yourself first, and then watch this for the ones you need extra help or just more explanation on. If you're not one of my students in my class, welcome. Hope you find this helpful for whatever class you might be using it for. So let's solve each proportion here. This is going to be a good recap of everything we've learned, at least if you're in my class, Mr. Wagner's class. And if you're in another Algebra 1 class, you probably have seen a lot of similar stuff to what you see here. You might have a final exam just like this, or with questions just like this. But solving each proportion, we're going to cross multiply. So we'll have 9 times 2 plus w, that whole quantity in parentheses. This is going to be 12 times 6 on the other side. Distribute the 9 through to both parts. That's 18 plus 9w equals 72. Subtract 18 from both sides, and then divide by 9, and you've got your final answer. W equals 6. You could check that by plugging it back in here at the top. This would be 8 on the top divided by 6 would equal 12 over 9. Both of those fractions would reduce to 4 over 3, so that does check out. This one, if we cross multiply, it looks like this. And putting both parts in parentheses there, distribute the 8, distribute the 6. That's 16 plus 8x equals 12x minus 18. And then from there, get the x's on one side, get the regular numbers on the other side. So I'm going to subtract 8x. That gets the x's over here, and then that would cancel here. I'm going to add the 18 to the other side. So I'll just show that all on the same line. Putting all this together, this will cancel. This leaves me with 34 equals 4x. I can divide both parts by 4 there. I can reduce that to 17 halves. I could also say that's 8 1/2 or 8.5. All those would be correct final answers. Just depends on what the directions say as to what kind of answer you're looking for there. Number 3, Alex paints a room that has 400 square feet of wall space, and he does that in 2.5 hours. At this rate, how long would it take him to paint a room with 750 square feet? So one way to do this is just to say that 400 over 2.5, that comparison would match up in the same way that 750, the larger room, would be to x. We're trying to solve for x. So how many hours does it take to paint the 750 if it's 400 matching up with 2.5? From there, cross multiply. 400x would equal 2.5 times 750. And let's see, that's 1500 plus 375. I have that written down here already, though. I had worked that out prior to this. This is 1875. So I can divide this by 400. And putting that in the calculator would give me exactly 4.6875, so that many hours. And so that makes sense. It should be a little less than twice as much, since 750 is a little less than twice as much as 400. It should be a little less than twice as much time-wise if we're saying at the same rate. So 4.6875 hours, final answer right there. Number 4. Find the final price. Compute the discount before adding the tax. So this one just has a discount. This one just has tax. This one has both. So on this one, we're saying 26 and a discount of 15. If you multiply 26 times 1, that's like multiplying it by 100% of the price. So we're subtracting 15% from 100%. This is really the easiest way to think about that. So this is the same thing as 26 times 0.85. So if you have a 15% discount, you're paying 85% of the original price. And so you just need to type that in to a calculator or work that out longhand, and you would get $22.10. Don't forget your units as you're doing these problems. So a shirt with a sales tax of 5.5%, you're going to be adding to 100% of the price. We're going to be adding 5.5% to that. So I'm going to take 1 plus and then move the decimal 2 spots. It's 0.055. So that's the same thing as 1.055. If you add those two things together, put that into a calculator, and you'd have $93.90. And for number 6, if we're computing the discount before adding the tax, we would want to find the discounted amount first. So 149.50, and then you could do 1 minus 0.25. Now with all of these we've done so far, you could find 15% of 26 and then subtract that value from 26. You could find 5.5% of 89 and add that value to 89. So that works just as well if you want to do that this way. Here you could find 25% of this, subtract it from that value. But I'm going to just do this because it's a little quicker. So we're paying actually 75% of the original amount, and then this times 0.75. That's going to be rounded off $112.13. This is the discounted price. Excuse me. Still getting over my congestion just a little bit. I've been sick the past couple weeks for quite a while. So we have here 112.13. Now we're taking that and we're adding 6% sales tax to that. So we would take 100% of that amount plus 0.06. That would be 112.13 times 1.06, and that's in a calculator $118.86 after tax. Number 7. So high school paper increased sales by 75% when it ran an issue, and I would say we're missing a word in there, for a contest, a little typo there, for a contest to win a class party. Before the contest, 10% of the 800 students bought the paper. How many students bought the contest issue? So if 10% of the 800 students bought the original paper before the contest, that would be 800 times 0.1 or 0.10, which would be 80 students that bought it before the contest. And then for the contest issue, it says that the sales increased by 75%. So we'd be taking 80. You could multiply that by 100%. That's no increase at all. But then add 75% to that. So plus 0.75. This would be 80 times 1.75, which would be 140 students that bought the contest issue. So that's it. Box that in. Final answer. Number 8, solve the equation for the variable specified. So we're going to solve this one for b. So it looks like I have the whole thing divided by 7. To get rid of that divided by 7, multiply both sides by 7 first. The 7 here would cancel with the divided by 7 there. You'd have b minus 4z would equal 7 times a, 7a. And then from there, add 4z to both sides since you want b by itself. You're trying to get the equation solved in terms of b. So b equals, this canceled. And then you could write 7a plus 4z or 4z plus 7a. Both would be the same thing. Typically we'll write the letters in alphabetical order, so I'm going to write it like that. For this one, we're solving for n. So trying to get the n part by itself first. Let's move this part over there. Let's subtract 4f first of all. That would be kn equals, then you could say 9v minus 4f, or you could say negative 4f plus 9v. With the minus sign, I usually put that in between if one's positive and one's negative, like that. And then here we want to get n by itself, so divide this side by k. If you divide the left side by k, you have to divide the right side, everything there as well, by k. And so that's it. 9v minus 4f over k. That's what n equals. That's it. That's your final answer on that one. Number 10, the population of a city in 2005 was 36,000, and then by 2006, so 1 year later, the city's population had grown to 43,200 people. If we assume that the population of the city has grown linearly, so a common difference, in other words, we're either adding or subtracting the same thing every time, and that it will continue to grow this way, what will the population be in 2015? Justify your answer. So show your work. So if we're saying from 36,000, 43,200, that it's a linear relationship, that means you have a common difference. To find that common difference, just do this one minus this one. So 43,200 minus 36,000, that would be 7,200 people per year. So this is thinking of that as either my kind of my m value, my slope value, or my d value. You can think about it one of those two ways. So this is the slope or the common difference. I'll say d, or you can think m. So in point slope form, this is the easiest way I think to tackle this one. Take point slope form. You've got, this is like an x value of 1 and a y value of 36,000. This is like an x value of 2 and a y value of 43,200. You could actually say this is year 0. I think that's even better. So to say this is the initial year, year 0, and this is your first year after that, this would be year 1. So let's say it like that instead. If you wanted to make an xy table, you could do that as well. But I'm going to use this value for my x1, y1. x1 is 0, y1 is 36,000. So y minus 36,000 equals 7,200. We're increasing by that amount each year. And then x minus 0. That's my x1 value right there. And so if I solve this for y, I would distribute the 7,200, but distributing to 0, it's still going to be 0, so this would just be 7,200x. I can add 36,000 to both sides, and that would be a good equation for me in a slope-intercept format. So this is saying y, the population, would be 7,200 times the number of years after 2005, and then that plus 36,000. So what's the population in 2015? I guess I could have circled this instead of boxed that. So I'm going to plug in now 15 for the x value. So this would be y equals 7,200 times 15 plus 36,000. And I'm misspeaking, or I'm not saying that right here. 2015, this is 10 years, not 15. So this is 10 years after 2005. Therefore, I want to plug in 10 here, not 15. So 10 plus 36,000, this would be 72,000 plus 36,000. So the population in 2015, assuming this linear growth continues in the same way, we're adding 7,200 each year, that would be 108,000 people that we would expect to be living in this city in 2015. So I'll put that in here as well. And if we instead suppose it's growing exponentially, that's when we have a common ratio instead of a common difference. We still use the same two numbers, but instead of subtracting, we divide. So 43,200 divided by 36,000. And if you do the division, if you do the work on that one, you're going to get 1.2. This is our common ratio. So this, in this exponential form, looks like this. We have an equals your initial value out in front, which is 36,000. Times the ratio here, so that's the 1.2, and then to the n, and it's minus whatever term you started with. So this one is minus 0 because we're starting with 0. So that would be your equation, And that's all it's asking for here. It says write an equation for the population. We just need to change it into this function notation. So P of t, population given a certain time in years, would be 36,000 times 1.2 to the, we replaced n with t, so to the t power. That's what we would write in the box up here as well. So I'll just write the same thing there. P of t, 36,000, and then 1.2 to the t power. Next up, we got number 11 here. So elephant population estimates in Namibia. Combined estimates for Etosha National Park in the northwestern population. So we have some elephant population data here. It says the elephant population in northwestern Namibia and Etosha National Park can be predicted by the expression, and then you have this expression here. This is your initial value. This is your ratio. Looks like 1 plus 0.045 is the idea there, and then to the b power, b is the number of years since 1995. So here's 1998. This is 3 years after 1995. So if we were to continue this up, 1995 would be the 0 year. And so we're trying to figure out, well, what would that be, or what does this number represent right there? That looks like it would be the initial value given year 0. So what is that? That's the predicted number of elephants in the region in 1995. So this one, choice B, is our correct choice there for number 11. 12, the cost of admission to Spring Carnival was $50 for a group. It looks like we missed the letter there, so, or a word there. A group of 9 children and 2 adults. The admission was $61 for another group of 10 children and 3 adults. What was the price of admission for each child and each adult? So we're going to say that C is the, we'll call that the child price, and A is the adult price. Here we're doing some systems of equations within the context of some word problems. Pretty simple one here to do though, because you have 9C plus 2A would have to be 50. That's based on this information right here. And then the other bit of information right here tells you the other equation. So 61 would have to equal 10C plus 3A. From there you could use substitution. So you could solve one of these for C or A and then plug it into the other one, or you could use elimination. I'm going to use that because it looks a lot easier to me. So I'm going to try to get rid of, I'm going to cancel out the A's here. So I'm going to say times 3 on this one, and then I want these two to be opposites of each other. So that would be 6A. So if I did times -2 on this one, that would be -6A on the bottom. So if I multiply that out, the whole thing times 3 would be 27C plus 6A equals 150. Here it would be -20C minus 6A equals -122. Combining those two equations together, the A's cancel. You'd have 7C equals 28. Divide by 7, and you've got C equals 4. And then you can take your pick of your equations you have here. I'll just go with the bottom one here. Plug in C as 4 and figure out what does A equal. So this would be 40 plus 3A equals 61. Subtract 40 from both sides there. That's 3A equals 21. Divide by 3, and you have A equals 7. So final answer, make sure you include units. We'd say $7 for an adult and $4 for a child. Box that in, that is it. Next up, number 13. Margie is responsible for buying a week's supply of food and medication for the dogs and cats at a local shelter. The food and medication for each dog costs twice as much as those supplies for a cat. She needs to feed 164 cats and 24 dogs. Her budget is $4,240. How much can Margie spend on each dog for food and medication? So we want to know the dog specifically. We might figure out the cat at the same time. It looks like that'll be a good thing to do. So let's say C is going to be the the cost for a week's supply for a cat, and D will be the cost for a week's supply, and we're saying a week's supply of everything, the food and the medication, by saying that for a dog. And let's see what we got here. So we have, this is definitely one equation right here. So we could say 164 times the number, or times the amount that a cat costs, because we have 164 cats. It's quite a few cats. And then that plus 24 times the number of dogs we have. This would be 4,240. That's one equation that we can come up with. There's another one, and it might be a lot easier than you're thinking. So this one, a dog costs twice as much as a cat. Therefore, D is or equals 2 times the cat amount. So if D equals 2C, this one's better to use substitution. We already have a variable solved in terms of the other one. So if D equals 2C, just replace D over here with 2C. So we have 24 times 2C. This is 4240. 164C plus 48C equals 4240. Combine like terms there, that's 212C is 4240. And then divide by 212. This gives you your cat price of 20. And then to figure out how much can Margie spend on each dog for food and medication, the dog is just simply 2 times that value, 2 times C. So a dog is going to be $40. So we can say $40 for a dog for a week's supply. And you could say it doesn't ask for that, but you could also say $20 for a cat. So I'll put that in parentheses. Why does it cost more to take care of a dog than a cat? Well, my opinion, because dogs are better, and because they're better, they just take a little more TLC, a little more tender love and care there. You can argue with me all you want, I suppose, but you're wrong. Dogs are better. Number 14, the water level of a river is 34 feet and is receding at a rate of 0.5 foot. You could say feet. I think that might be a little better to say feet per day. So write an equation for the water level L after D days. So if we're starting at 34, I really don't mind if you just use slope-intercept form. So think about y equals mx plus b. B is what you're starting at, and then your m is what you're increasing or decreasing by. That's your slope. So this is like my b value, and it's receding at 0.5 feet a day. So receding means you're subtracting. So this is going to be your m, but it's going to be negative 0.5. If you think of it like that, you have y equals negative 0.5 x plus 34. And if we're going to write this in terms of L and D, that simply looks like L of D in function notation. The level given a certain number of days would equal, and you could say, just like it is here, negative 0.5, but then times D plus 34. If you wrote 34 minus 0.5 D, that would work as well. If you wanted to use point slope form, you could do that here as well. You would just use 0 and 34 for your x1 and y1 instead. In how many days will the water level be? 25 or 26 feet, excuse me. So we're saying the level is 26. That means we want to replace right here, we want to replace the L with 26, not the D with 26. So we want the L of D part to be 26, and then we'll need to solve for the D part over here. If we subtract 34 from both sides, that's negative 8 equals negative 0.5 D, and then divide that by negative 0.5, and this would become positive, negative divided by negative, and this would be 16 right here. So 16 days is my units. That would be what D equals right there. Looking next then at number 15, let's say Michelle here is spending money at the average rate of $9 per day. So she's spending money at a rate of $9 a day. That tells me that M equals -9. And then after 14 days have passed, she has $108 left. So that means your X1, Y1 is going to be 14 and 108. So that's X1, that's Y1. The amount of money, M, depends on the number of days, D, that have passed. So let's write an equation for this situation. Now we definitely want to use point slope form. So Y minus Y1 equals M times X minus X1. Point slope is necessary here because we're not starting at 0. Back here, we were starting at day 0. So we could just use slope-intercept there. But now we're starting here. This is going to be Y minus, starting at 14 days, $108. So Y minus 108 would be -9 times X minus 14. And then let's work this out from there. This would be -9. Distribute the -9 through. You have -9x. This would become negative times a negative positive, and that would be 126 right there. From there, add 108 to both sides. And it looks like that would leave you with Y equals -9x plus 234. So in terms of the function notation that it gives us, M and D, we use that instead. So money given a certain number of days equals -9 times the number of days plus 234. So then here, use your equation to find the amount of money she began with. So the money she began with, there we're saying this is day 0. This is after 14 days, but this would be day 0. Or in other words, D equals 0. So we're going to plug in 0 for D. That's going to tell us the amount of money she began with. So M of 0 equals -9 times 0 plus 234. -9 times 0, that part drops out, and so your answer is 234. So she began with $234. And then use your equation to find how many days before she has no money left. Well, if she has no money left, that means your M value is 0 instead of your D value. So this one we're saying M of D, the M, the whole thing, equals 0. Therefore, you're saying 0 equals, and then we have -9 times D plus 234. Solving that for D, we'd add 9D to both sides. So 9D equals 234. Divide everything by 9, and that gives you your answer. D equals 26 days. So after 26 days, the money is gone. Number 16. Painter A determines how much to charge his clients using the table below. So it looks like it's going up by 20 each time. So this would be, I'm going to complete the table first here, 130, 150, 170, and so on from there. The rate of change or slope, here we're adding 20. Every time we add 1 here, the same pattern continues. Add 20, add 1, add 20, add 1. So the slope, the M value, is your change in Y over change in X, which here is change in T over change in H. So 20 over 1, which is just 20. Using your table, what is the value of T of 0? So if you add 20 going this direction, you're going to subtract 20 going this direction. So if you had a 0 and you subtracted 20 from 70, you have 50. Essentially, that would mean that the painter is just going to charge you $50 just for showing up and not working at all. And that happens in real life. You have plumbers, electricians, something like that. They have to make a call. They'll charge you just to show up, even if they're only there for no time at all or for a minute or two. So 16c, find the equation for the pattern t of h. So here, now we can use one of these points and use point slope form. So let's use this right here. And we're saying t of h, we'll get to the function notation at the end. So we're going to say y minus y1, m times x minus x1. We're plugging in 70, we're plugging in 20, and we're plugging in 1 for those values. So y minus 70, distribute that 20 through, 20x minus 20, and then add 70 to both sides. This cancels. Y is 20x plus 50. That means that in function notation, what it has here with t of h, that would be t of h, the total cost given a certain number of hours equals 20 times the number of hours worked plus 50. And if you know that equation, then finding t of 20 is very simple. You just plug in 20 for h. So 20 times 20, this is what the painter would charge if he was there for 20 hours. So this would be 400 plus 50, or $450. Let's take a look at number 17. So for 17, state the independent variable and the dependent variable in the situation, and then find the average rate of change for the situation. Include units for the rate of change. So we're looking for what depends on what. If you go to a grocery store, the amount you pay depends on how much you buy. So dollars would depend on pounds in this case. So the dependent variable is the dollars. And that depends on how many pounds of apples you buy. So the average rate of change is going to be the change in y over the change in x. Independent is always like your x value, and dependent is always your y value. So change in y over change in x, we're saying the change in dollars then over the change in pounds. LBS is an abbreviation for pounds, so I'll write it like that. And so we're saying here, what's the change in dollars? Well, that's 1194 minus 398. What's the change in pounds? That's 6 minus 2. This would be, it looks like that's going to be, I did the work on that earlier. I should know this off the top of my head, but I'm starting to lose my focus a little bit. Hopefully I'll be able to maintain the focus as we finish this video here. So $1.99, if you divide those two things, that would be $1.99 per pound. You could say $1.99 per pound, or you could say $1.99 per pound like that. That would work out just as well. So that would be your average rate of change. Every time you add 1 pound, you're adding $1.99 to the price. That's another way to describe that. Number 18 through 21, graph the line, naming the method used for each graph. So I'm going to use what I feel like is the easiest way to graph these things. On this one, since 12 is a multiple of 6 and 3, I think y-intercepts is the easiest way to go about this one. So if you plug in 0 for y, that's going to give you your x-intercept. If you plug in 0 right here, this part goes away, and 6 times 2 equals 12. Therefore, 2, 0 is the x-intercept. For the y-intercept, that's where x equals 0. So if you plug in 0 for x, that part goes away. -3 times -4 equals 12. You could divide by -3 if you needed to help you figure that out, but this would be -4 right there. And so x and y intercepts, I think it's pretty clear that that's the method we used right here, since I'm writing that right there. But I'll just write it just for the sake of clarity. So x and y intercepts is the method we used. And then just plot those points and connect them with a line. So 2, 0 would be 2 to the right, 0 up and down. 0, -4 would be right there. Connect those with a line. And we are we're good to go. So that pattern would continue. So I just need to make sure that's up 4, right 2, up 4, right 2. Yep, it looks good. So that one, I'll do that one in blue there. I'll do this next one in green. So this one, y equals 2x minus 2, I would go with slope-intercept form for this one. It's already written in that form. This right here is your intercept, or your b value. This right here is your m value, or your slope. So slope right there, intercept right there. So start by graphing the intercept, or by plotting that point, and then from there your slope is 2. That's the same thing as 2 over 1 for m. So go up 2, right 1. Same pattern continues, up 2, right 1. It looks like these two lines are actually parallel to each other, because this is the same thing as going up 4 and right 2. If you divide 4 and 2 by 2 each, you'd have 2 over 1 instead. So here's the green line, the 19, or line 19, the line 419 is right there. And I'll just move that over in just a moment. It's not quite on the dots there perfectly. That's a little better. There we go. And so good to label these two. I know I color coded them, so it's probably obvious, but if you're using pencil, definitely label which one is which. Number 20 and 21. This one looks like it's in point slope form already. So I'm going to say point slope form is the method I'm using. And then this is in this y minus y1 equals m times x minus x1. That's the general point slope form. Therefore, we have a point at x1, y1. This is like x minus negative 3 is the way the form looks. So this would be the opposite of what you see there for the x coordinate. So negative 3 is your x coordinate, because x minus negative 3 is the same thing as x plus 3. And then this is y minus y1. So y1 is the number right there after the minus sign. y1 would be 3. So a point on this graph, or the graph of this line, would be negative 3, 3. And the slope of that is going to be the value right here, the m value in front of the x part. So we have negative 1/3. We go down 1, right 3. We'd have a new point. Down 1, right 3. We'd have a new point. That pattern would continue going this way and this way. I will draw a line connecting those at this point. And so that looks like this, and I'll just slide that down just a skosh there. There we go. And this would be number 20. 21. You could solve for y pretty easily. You could subtract x and then divide by negative 6. That would get you a slope-intercept form. Point slope, that would take some work there to get this in point slope form. You could make an xy table. We haven't talked about that one yet, but the easiest way, I think, is to look back. 18, this number was a multiple of those two. Same thing here. This number is a multiple of negative 6, and you can think of that as a positive 1. So I'm going to use x and y intercepts again. It's not the only way you can do this, but I think it's the easiest way you can do this. So this would be y value of 0. If the y is 0, this part drops out. 1 times 6 is 6. So that would make that 6, 0 as the x-intercept. The y-intercept would be where x equals 0. So that part would go away. Negative 6 times negative 1 is positive 6. Therefore, this would be 0, negative 1. So this is in, or this was, x and y intercepts method. And I'll box that in here as well, since it's asking specifically, naming the method used. Just keeping up my good habits of boxing answers, making it easy to see what I meant or intended my answer to be. So 6, 0 though, this graph only goes to 5, so we'll just have to keep the scale consistent. 1, 2, 3, 4, 5, and then go one more. So 6 would be right about there, 6, 0, and 0, negative 1 is right there. If we connect those with a line, we're all good to go. And I'll just slide that up a little bit so it's correct. There we go. So it's going to cross right about here. You'd go up 1, right 6, up 1, right 6. That pattern has to hold. That pattern has to continue. This is 21. All set with 21. 22 now. The table shows the number y in thousands of alternative fueled vehicles in use in the United States after 1997. So this is the year after 1997. So 0 years after 1997 would be this one. This is 1997 right here. This is 1998. That's 1 year after 1997. 1999 and so on. Use an equation then for the line, for the best fit line, to predict the number of alternative fueled vehicles in the United States in 2010. So this 97, 98, 99, 2000, 1, 2, 3, 4. We're going to use an equation from this data to come up with a prediction for that value. So let's plot these points right now. And it looks like it goes from 0 all the way to 300. So I'm going to make a little line break right here, just showing that there was some data or some of the graph missing there. We're going right from 0 to 300. So let's say this is about 250 right here now. We're going to plot 280. 0, 280 would be right about here. 1, 295, very close to the 300. 2, 322, almost halfway in between 300 and 350. 3, 395 would be right about there. 4, 425, exactly halfway in between 400 and 450. 5 and 471, right about there. 6, 511, just a little above the 500, and then 7, 548, very close to 550 right there. So there's not a perfect line that connects all of those, or those are not in a perfect linear relationship, but there is a best fit line. So we're going to draw one that looks close. We're not figuring that out exactly in Algebra 1. There's ways to do that exactly that you learn about in future math classes, potentially, but we're not going to do that here. So the line of best fit, we're just going to draw a line that approximates that data fairly well as best we can. So I would say that's pretty good right there. And let's pick 2 points that are actually on the graph. That's really what we need to focus on. So I can pick this one. It happened to be one of my data points. It doesn't have to be a data point, but it could be. But I couldn't pick this one or this one because they're not actually on the line of best fit that I drew. This one right here, this looks like it is. So I could use those 2 points to come up with a slope and to then come up with an equation for this line. I could also have used another point of my choosing. So I could have picked 1 and then made an estimate for that, maybe 320, something like that. That point would have worked out just as well. But I'm going to go with the 2 points right there. So that right here, for my slope, let's start out with that. The slope would be change in y over change in x, or y2 minus y1. I can think of it that way as well. So y2 minus y1 over x2 minus x1. The 2 points I picked are actual data points here in the table, but they lie on the line again. So if they don't lie on the line, you can't pick those ones, but these ones do, so I could use these ones. So 425 minus 280 over 4 minus 0. So it looks like that's going to be, I'm going to need to get my calculator out here a second. So I don't necessarily need that for this part here, but I might need that later on. So this would be 4, and this would be 145, it looks like, if I subtract that minus that. And so if I put that into a calculator, 145 divided by 4 is 36.25. So if your line of best fit was slightly different than what you see here, but it's still approximating the data pretty well, I definitely could see you having a slightly different slope. It should be fairly close to what I have here, to the 30, and I'm forgetting what I typed in already there, 36.25, yes. So fairly close to that. I'm going to be using that for my slope since I had used those two data points. So from there, now that I know my slope, I can use point slope form. I know a point on the line. I'm using this point or this point since they're actually on the line and just plugging those things in. So I'm going to go y minus 280 equals the slope 36.25 times x minus 0 in this case. I'm using this point in point slope form with this as my slope. This is my m value. So from there, y minus 280 equals 36.25. Distribute this, distributing to 0, that part goes away, so this would just be that. I can add 280 to both sides, and that gives me 36.25x plus 280. And if I'm trying to find the number in 2010, this, remember, it was the years after 1997. So 2010 minus 1997, that would be 13 years after 1997. So we're going to plug in to find for 2010. Why don't I say, instead of so, why don't I say 4 through 2010? Here I'm plugging in 36.25 times 13 plus 280. If I type that in, 36.25 times 13. I'm hitting the wrong button there. Having a little trouble seeing that. Yeah, that's good. Okay, so 36.25 times 13 plus 280 equals, and it looks like 70 or 751.25. And this is in thousands of vehicles, so we would say this many thousands of those alternative fueled vehicles. So that many thousand vehicles. Now if you used different points or you had a slightly different line of best fit, you might have something slightly different than this, but it should be within, I would say, 50 one way or the other, within 50,000 vehicles, depending on how you drew your line of best fit. Number 23 though, let's take a look at 23. It says graph the line here. This is in point slope form already. So this one, you have a point, and this would be x minus -3. It's always the opposite of what you see. So the point's at -3, and here you have y minus 1, so that's the opposite of what you see for the point. 1 is the y value. So -3, 1. And then you have a slope right here of -2/3. So the slope equals -2/3. So from here, go down to right 3. Down to right 3. Connect those with a line. And how about I draw a blue line, not a purple line. And that looks pretty good to me right there. This one is number 23. So I'll label that as such. And then it says, or this is all 23, so why don't I call that the original instead? So I'll go like that. That's the original line. Then draw and give the equation of the line perpendicular to the given line through negative 1, 1. So I know I'll go green for the perpendicular part. Negative 1, 1 has to be a point on that perpendicular line. So I'll start by drawing that, and I'm going to give the equation of it. So in point slope form, if it's perpendicular, the slopes have to be opposite reciprocal. It has to be the opposite reciprocal. So the opposite reciprocal of negative 2/3 would be, flip it, that's negative 3/2, and then make it the opposite of what you see. So positive 3/2 would be the slope. And then in point slope, this is your point, this is your slope, this is your new m value, and then this is your point, this is your x1 comma y1. So in point slope, we're saying y minus y1 equals m times x minus x1. Plug in the values. Y minus y1 is 1. So y minus 1 equals 3/2 is the slope. And then x1 is negative 1. So you have x minus negative 1. That would be x plus 1 after you simplify the minus a negative. This would be the equation. And we want to make sure that the slope is the opposite reciprocal. So that was up 3, right 2. You could also go down 3 and left 2 would be the same thing, because negative 3 over negative 2 is the same thing as positive 3 over positive 2. So that pattern continues going down this way. Connect them with a line. I'll make mine green. And it looks like I'm good to go right there. So this would be the perpendicular line. Perpendicular means they're meeting at a 90-degree angle. So there you could actually draw a box in the corner. When you draw it, it should look like it's actually perpendicular. If it doesn't look perpendicular, you know you did something wrong. So here's your equation. Here's the perpendicular line. Here's the original line. 24. Graph the line y equals negative 4. And then draw and give the equation of the perpendicular line through negative 2, 2. So let's start by graphing this one here. So if y equals negative 4, it does not matter what x value you pick, y is negative 4. So if you pick 0, y is negative 4. If you pick 1, y is negative 4. If you pick 2, y is still negative 4. You're going to have, anytime you have y equals, that's a horizontal line. So right there, horizontal line, connecting those points. This is your original line. And then draw and give the equation of the perpendicular line through this point. So it has to include that. So let's start there. Negative 2, 2. If it's perpendicular to a horizontal line, that's a lot simpler than what we were doing here. It's just a vertical line. So perpendicular lines and perpendicular lines, we have horizontal and vertical are perpendicular to each other. Horizontal would be parallel to a horizontal, but perpendicular you have to have at a 90-degree angle. Back here, if it would have said parallel instead, that would be the same slope. So don't forget that. That could show up on the final exam as well. But perpendicular is opposite reciprocal. So here, with horizontal, just think vertical instead. And you can just draw a vertical line through that point right there. You draw that and you're done. You're good to go. This is the perpendicular one, so I'll label it the perp. And draw and give the equation. So what's the equation of that? Well, you go back 2 for the x value. And you're always at negative 2 for the x value anywhere you go along that line. Therefore, your equation for the perpendicular line is simply that, x equals negative 2. Next up, number 25, graph the system of equations and then determine whether the system has no solution, one solution, or infinitely many solutions. If it has one solution, name it. So from here, let's graph these lines. This one, it looks like slope-intercept form might be the best way to go. Since 8 is not a multiple of negative 3, x and y intercepts don't work out quite as nice as they might normally. So let's solve this one for y. So adding 3x and then dividing by 4 will do that for us quickly. So we have y equals 3/4 x plus 2. This is your y-intercept right here, and this is your slope. So go over to the graph, go up 2, start there. That's your y-intercept once again. And then this is your slope value right there. So up 3, right 4. You could also go down 3 and left 4. If you connect those with a line, it looks like that. And so that was our initial one. I'll have that one in blue here, and then this one, I'll do this one in green. Could subtract 6 and then do x and y intercepts, or we could just go with the slope-intercept form. I'll do that here. I'll go slope-intercept. So I'm going to subtract 6 and subtract x from both sides. I'll just do that in the same step here. You've got 2y equals, and you'd have negative x minus 6 is the same thing as negative 6 minus x. Divide everything by 2, and you have y equals negative 1/2 x minus 3. So here on this one is your slope, and here is your y-intercept. So go to negative 3, and then you're going down 1 and right 2 if you have a slope of negative 1/2. Down 1, right 2. Or up 1, left 2. Up 1, left 2. And boom, there's your intersection. So this one has one solution. If you have parallel lines, it's no solution. If you have lines that are right on top of each other, we call those coincidental lines, you have infinitely many solutions. But this one, we just have one solution. They only cross in one place. We connect those with a straight line, and we're good to go. We just need to say now that it had one solution, we need to name that solution. That solution is right here. It's that point right here. It has one solution to this system, and the solution is, looks like negative 4, negative 1. (26) and 27 use either substitution or elimination to solve the system. This first one, 26, looks like substitution's a little bit easier because you already have it solved for y here and here. So you have y equals negative 4x minus 2. Just replace y with that expression over here. So y becomes negative 4x minus 2. And then it's simply a matter of solving that for x. So you can add 5x to both sides. And then that would move the x's to the left. So I want to move the regular numbers to the right. Add 2 to both sides to do that. This would be x equals 16. So that's one part of the puzzle here. We're solving the system though, so we need x and y. So I can take my pick now. I could plug in x is 16 in this one, or x is 16 in this one. I'll just go with the one that's right here. So I'm going to plug that in. Y equals negative 4 times 16 minus 2. That's negative 64 minus 2, so y equals negative 66. Great idea whenever you can to check your answers, plug them back in. We know it's going to work in this one. If you plug 16 into this one, you'd have negative 80 plus 14. That would equal negative 66 as well. So substitution, that worked best, I would say, over here. This one I think though is a good elimination problem. So elimination I think is going to work well, work a little more quickly on this other one. Let's rewrite both equations, but write them one on top of the other. So we've got 3x plus 3y equals 9. And if I pick a number that I want to get, or pick a variable I want to get rid of, let's do that. I'm going to go with eliminating the y's first. So if I do times 3, and times negative 2, I'll have 6y and negative 6y. They will cancel each other out. So let's see what happens when I do that. I would have 15x plus 6y equals negative 9, and I would have negative 6x minus 6y equals negative 18. If I add them together, put them together, I get rid of the y's. This is 9x equals negative 27, and divide by 9, x equals negative 3. And then take your pick once again, decide what equation you want to use. I'll just use the bottom one. So 3 times x, 3 times negative 3 plus 3y equals 9. Negative 9 then plus 3y equals 9. Add 9 to both sides. 3y equals 18. Divide by 3. There's your y value. There's your solution to the system. Negative 3, 6. This one, your solution is 16 and negative 66. So let's check out now 28. 28, graph the system of inequalities. So with systems of inequalities, we need to think of it like there's an equal sign initially, and then we shade one side or the other, and we make the line solid or dashed depending on whether it has an or equal to part in it. So think of this as x equals negative 3 first of all. I'll do this one in blue. So x equals negative 3 would be right here, and a vertical line going along there. But it's not or equal to, so this is a dashed line. So I'm going to get my dashed line tool out here. Draw that in blue. There's my dashed line. And I'm saying greater than negative 3, so I'm going to be shading in this direction. So I'm just going to make a little arrow like that to remind me that I'd shade to the right of that. Y is greater than negative 1. I'll do this one in green. Think of it as y equals negative 1 at first. So right there, y equals negative 1. And you'd have a horizontal line there. It's not or equal to, so it has to be dashed instead of solid. So I'm going to draw a dashed green line right there. And we are saying things that are greater than negative 1, so that would be above that line rather than below that line. And then finally, I'll do this part in red. Think of this as y equals at first. This is your slope, negative 3/4. This is your y-intercept, positive 2. So start there, go up 2, and then go down 3, right 4. Could also go up 3 and left 4. So draw that line once again, though, not or equal to, so another dashed line here. So it looks like that. I'm just going to get that right on the dots there. That's a little better. And we're saying this is less than. So it's going to be stuff in a way you were thinking below that line or underneath. I know I talked about the roof idea if you're one of my students. So think of this as a roof. You're shading underneath the roof. This would be stuff underneath the roof right here. So if you shade this one down this way, this one up this way, and this one to the right, what will they all have in common? They'll have this section here in common. Get the orange out for that. So they'll have this part here in common. So shade all that in as the dark final solution or final region for your answer. Let's take a look now at 29. So the owner of Fred's Fish Market orders cod and salmon. He wants to buy at least 50 pounds of fish, but cannot spend more than $300. Cod is $4 per pound. Salmon is $7 per pound. So I'll color code a little bit here again. So X is the number of pounds of cod, Y is the number of pounds of salmon. He wants to buy at least 50 pounds of fish. So we know that X plus Y would have to be at least 50. X plus Y, in other words, would have to be greater than or equal to 50. For the other parts, cannot spend more than $300, and we're told that cod is $4 a pound, salmon is $7 a pound. So we would say cod, 4x, plus the salmon, 7y, cannot spend more than 300, would have to be less than or equal to 300. So on this one, we could use slope-intercept form to graph this. I think this one, though, let's just go with x and y intercepts for both of these. So this one, the x-intercept would be, if you cover up the y, if you say y equals 0, 50, think of this as equals for right now, so 50 equals 50. That's what we would want for my x-intercept. For the y-intercept, that's where x equals 0. Same thing, cover this up, 50 still equals 50. So if I were to graph the blue inequality, it looks like this. We have x and y intercepts there and there. Connect those with the line. This is or equal to now, so it's going to be a solid line instead of a dashed line. And I would just connect those. I'll keep that blue there. Just connect those like that. And we're saying greater than or equal to, so we are going to be shading above this line. So I'll just make a little arrow like that to note that for now. And we'll shade what they have in common in just a little bit. So this other one, 4x plus 7y, is less than or equal to 300. If I use x and y intercepts again here, I'm going to have some rounding off on one of these, but that's okay on this one. I really just want a region. I'm not looking for an exact specific number here. So 4x, 7y. If you plug in 0 for y, that's going to be your x-intercept. So if you plug in 0 here, what makes this true? 4 times 75. You could divide both sides by 4 there, and you would find that x equals 75. Again, think of this as an equals for right now. If you plug in 0 for x, then you're looking for what makes that true. So I would get out my calculator, do 300 divided by 7, and if I did that, I'd get about 42.9. So let me get rid of the scribble there. There we go, 42.9. So the y-intercept, 42.9, would be right about there. And the x-intercept, 75, 0, that would be right about there. Connect those then with a straight line. And this one we're shading below. We're going underneath there, so we're saying less than what we have there. So what would they have in common? If the blue one's shaded above and the green one's shaded below, they would have this little section in common. This is where they would intersect. So anything in this region would be less than $300, but more than 50 pounds of fish. And then anything on the lines would be the or equal to part. So anything in the region or on the lines would work. This would be less than or equal to $300, greater than or equal to 50 pounds of fish. So which points are actually solutions? Let's graph all those points. 40, 15, that is in the region, so yes to part A, or to choice A there. 50, 18, that is a little outside the region, so we would say nope, not B. C, 30 and 20, that's right on the line right there, so that's okay. Since this is a solid line, that would work. 55, 8 would be right about here, and then right about there. So 55, 8, that's good. And then 20, 35, 20, 35, nope, that one's not going to work. So that one's not in the shaded region. And number 30, write two inequalities represented by the graph below here. So the blue one, I'll just use the colors that are there. The blue one, it looks like we have points if we look very carefully, got a point right there that crosses the grid line, a point right there. Looks like you're going down 2, right 3, down 2, right 3, down 2, right 3. And just make sure that pattern continues and doesn't start to drift off the line. Looks like we're good to go. So that pattern keeps going like that. So this one, the blue one, is going to have a slope of negative 2/3. What's the y-intercept? If you look at where it crosses the y-axis, that's at negative 3. Therefore, an inequality to represent the blue line would be y, and it's shaded above here. That's the only way this part could be shaded and not anything underneath there. So it's going to be y is greater than, and it's solid, so it's or equal to, and you have negative 2/3 x minus 3. Those two values coming from right there. So this is the blue line. This is one of the two inequalities. For the black one, it's dashed, so you're not going to have or equal to. This is where the x value is always 5 along that line. So we say x is, and we're shading to the right here. So x is greater than 5 is what that one is. And then finally 31 and 32. We've made it to the last page there. What is a function? I think this is the best way, or the easiest way, to think about what a function is. So for every x value, or every input value you could think of, there must be only one y value. So on this one, if you look at the x values 1, 2, and 3, 1 has only one y value attached to it. So 1 only goes to 2. That's good. But here 2 goes to two separate numbers. You can't have a function if you have an x value or an input value going to two separate output or y values. So this one is a no. It doesn't satisfy the definition here. For each x value, some of them have more than one y value. So that one, sorry, no dice, not going to work out on that one. So the domain is all possible input values or all possible x values. And the range is all possible y values. And I think I want to come back to this one, so we'll take a look at this one in just a moment. But let's go back, or let's go to these ones. So on these ones, again, every x value, there must be only one y value for that x value. So 1 just has 1, 2 just has 4, 3 just has 9, 5 just has 25, and 10 just has 25. It's okay if two different x values go to the same y value. It's not okay if one x value goes to two different y values. So this one is a yes. Each x value goes to just one and only one y value. The same thing is true here. Each x value goes to one and only one y value. There's no repeating input numbers. So each of these is different. It doesn't matter what they go to then. If they had repeating ones, so for instance, if there was another -6 and it went to a different number, like instead of 7, maybe it went to 5. If you had -6 going to 5 and -6 going to 7, then you'd say no. However, that's not what we have here. We have -6 only goes to 7, -8 only goes to 9, and so on. There's no two output values for a single input value. So this one, yes, it's a function. The same idea holds for what you see here. So you pick any x value along this graph with its corresponding y value. There can only be one y value per x value. If you go along here, you're okay until you get to right about there. So if I draw a vertical line, I'll do this in green, that's fine. If I draw a vertical line like that, and I move it along the function or the potential function, it's okay until I get to here, and then all of a sudden I have an x value of -1 matching up with two different y values on the relation. Now on the function, it's not a function because of that. So I almost misspoke myself there. This is not a function because you have the vertical line test is what we call that, a quick way to describe that. The vertical line test shows that you pick any x value between -1 and 1, you're going to have more than one y value corresponding to that. So this one, because it does not pass the vertical line test, it is not a function. And in other words, for every x value, sometimes there is more than one y value, anywhere from this range from -1 to 1. That happens on this graph. So is this a function? No, it is not. And finally, number 32, last one here. This should actually say 32a, 32b, 32c, 32d. So g of 2, if you look at the graph, g of 2, I'll color code things since it's color coded here. G of 2 would be this value right here. -2 is the y value. If you plug in 2, the y value is -2. So this is just function notation, just looking at the graph. You say -2 is the same thing as g of 2. And then f of -3, if you go back 3, what's the value on the green line? It's also -3. So this would be -2. If you write them right next to each other, it's that times that. So -2 times -3. Merry Christmas right there. Oh, I see what you're doing there, Mr. Wagner. Nice. So green and blue, or green, red. Yeah. So negative times negative, that's positive. 2 times 3 is going to be 6. G of 2, we already know that. If we go to the right 2, the value on the g of x line is -2. So this is -2. That's going to equal k is what we're going to try to figure out. K is a constant term here. And then f of 2. If we go right 2, what's the value on the green line at 2? It's +2 right there. So this is k times 2. Another way to write this would be 2k equals -2. K times 2 is 2k. Divide both sides by 2, and you have your k value at -1. For 32c, over what interval is g of x less than or equal to f of x? So basically all that's saying is, when is the red line below or equal to the green line? So if you look at the graph here, the red line is above the green line until it gets to right there at -1. And then from that point and beyond, it's either equal to or less than the green line. So right here, that's all we're saying. We're saying that over what interval is that true? We're saying that x would have to be greater than or equal to -1. And then over what interval is f of x greater than 0? Well, if you look at f of x, it's the green one. Up until 0, it's less than 0. So up until 0 for the x value, but right there it becomes 0, and then after that it's greater than 0. So this one we would say x is greater than 0. That's the interval where f of x, the y values for the green function, become more than 0. I forgot one thing back here. I said domain and range, what they were, but the domain here, what is it on this one? We're asked for that specifically. It is all the possible x values 1, 2, and 3. And the range, all the possible y values, all the values I see there, 2, 4, 6, 8, and 10. If you had to give that for these, you'd say domain is 1, 2, 3, 5, 10. Range 1, 4, 9, and 25. Domain here, -8, -6, 0, 6, and 7. range 9, 7, 0, and 6. We wouldn't have to repeat the 7 twice. And then for the graph here, the domain, looks like you could plug in anything for x. This would continue going forever this way and this way. And it looks like you could also have anything be a possibility for y. It's going to keep growing, going up and up and up. Maybe more and more slowly, but still going up and up and up. So I think that does it. If you noticed any mistakes I made, please let me know. Please make a comment. Let me know the time that the mistake was made. I can fix that, or at least I can make a comment or make an annotation in the video so that others won't deal with that same mistake. But if you liked the video, if you appreciated it, feel free to hit the like button, the like button, the like button, or leave a comment just saying thanks. I appreciate that. If you had anything you were wondering about, feel free to comment on that as well. Please just use this as you see fit. Make sure you're ready for the final exam. If you're one of my students, go back and review as many times as you need to. That's what it's there for. Hopefully you find it helpful. If you're not one of my students in class and you're just watching this just to get some help, hopefully you found it helpful as well. It is late for me right now. It's time for me to go to bed. I'm starting to lose my train of thought here. So have a great day. I hope you enjoyed the video. Hopefully you found it helpful. And I'll see you later for another video in the future. Have a good one.